Hi guys, Renaud from Defensionem here. In a minute, I'm going to take you on a virtual tour, a virtual visit of 3 modern Belgian fortifications. When I say modern fortifications, I'm talking about forts that were built from the 1800s onwards. So forts that saw action in the First and Second World War. Before doing that, I need to give you a quick rough introduction into fortifications in general. And I'm going to oversimplify a lot because I'm constrained by time and it's a very, very technical field. But fortifications have existed for a very, very, very long time. If you go to Britain, you can find ruins of hill forts that go back to the late Neolithic and early Bronze Age. So almost as soon as humans started developing kind of advanced weapons, they started developing fortifications. And from then on, it's really been a race between offensive weapons and defense. And as offensive weapons developed, including siege weapons, the fortifications also evolved. So an early hill fort could have been just a wooden palisade around a village. And slowly but surely, you see some variations of that, sometimes using stone walls and so on and so forth. But it remains relatively simple, at least in Europe, as we advance toward the Middle Ages. You start seeing fortified homes in the Middle Ages, and then you start seeing the appearance again, really simplifying here and rushing through time. You start seeing the appearance of motte and bailey type fortifications or stone keep, later called Norman keeps. And then we start adapting to better siege equipment and long range equipment. So you start having various different walls, outer walls built, more depth, more curtains, more towers. Those walls are getting taller. And it goes on up until the appearance in Europe of gunpowder. And that doesn't change the game immediately, but it will at some point change the game. So medieval fortresses are adapted to become gun platforms. Gunpowder improves, artillery improves, and suddenly those tall walls are becoming more of a target than a good defensive position. So the walls start going down slowly and gaining more and more in depth. And that's a natural evolution toward the star fort, Vauban style fortifications, where the fort become mainly gun position, gun platforms. But it doesn't stop there. Indirect fire comes into play. Range of weapons come into play. And those walls need to keep on going down and down, and forts need to be better and better protected. And then we end up very quickly to this type of fort. This is early 1800. This is the fort on the Western Height in Dover. It's basically flush with the landscape. You don't see the fort up until you walk all the way to the outer wall. And then you have your dry moat and the fort there and then. Originally, from where the picture was taken, you would have been standing level with a gun bastion. And the top of the fort is covered with packed earth to protect it from indirect fire. And that's already in the 1800s. Now, if you carry on a little bit, and as you see with the first generation of modern fortifications in Belgium, you start finding, bricks, stones, and then concrete. So concrete forts were brought in Belgium in the early to mid 1880s by a military architect called Alexis Brialmont, and he designed those very modern forts which are completely underground and covered in packed earth to protect the structure from long-range indirect artillery fire. And this is where we're going to start this virtual visit. So we're going to go now and visit Lantin Fortress, which is a small Brialmont type fort near Liège. Here we go. So we are in front of Lantin Fort. Lantin is what I would consider one of the first modern fort as far as Belgian forts go. It's a first generation modern fort. It's a Brialmont design. They were built in the 1880s, and they represented a radical shift away from classic fortifications. Fortifications up until the 1880s or the mid-1800s really towered over the landscape, whether we are talking about medieval forts with their big walls and big towers, or whether we are talking about Vauban style forts with bastions. They were visible from far away. As artillery became more and more potent, military designers and architects had to find a way for fortifications to keep up with that and be better protected. So the wake-up call for the Belgians really came after the Franco-Prussian War. The Prussians were nice enough that time to go around Belgium, but they won a thorough victory against the French. And France at the time was probably one of the biggest, most powerful military on the planet. Brialmont, which was a Belgian architect, received the authorization to start building forts. A war between France and Germany was inevitable, and unfortunately for Belgium, the fastest way really to France from Germany, or to Germany from France, is across Belgium. You know, you enter from France into Namur, or you enter into Belgium from Liège. So Brialmont designed those modern fortifications, and he designed them as supporting forts, organized as a crown around cities. So you had 12 forts around the city of Liège and 9 forts around the city of Namur. They're all about 3 to 5 kilometers from one another. Therefore, every fort can receive fire support from its 2 flanking forts. The idea with that was that the Germans would have to attack 3 forts simultaneously to hope getting through at least one, and then through into Liège or into Namur. If we have a look at the design, well, the landscape has changed a little here since 1880, but you can see that the fort is much lower. It blends into the landscape. It's semi-underground. It is still a monolithic structure. It's one big building surrounded by a dry moat, but it is covered in packed earth and it blends into its surrounding. Brialmont forts were surrounded by dry moat. Those dry moats were defended by coffers. We can see them there. Coffers basically played the role of a tower on a medieval castle. It just defends the moat. Turns out that on modern fort, the moat is inside the outer wall, not outside. Those forts were made completely out of concrete. That was a new material in the 1880s. And the armament was mainly composed of steel gun turret. That also was kind of brand new at the time. So as far as 1885 or 1888 was concerned, those were very modern forts. Unfortunately, they were not perfect. There were some shortcomings in the design. There were some shortcomings in the constructions, and they were not modernized or modified. So by 1914, when the Germans inevitably came through and invaded Belgium, those forts did a fantastic job at slowing them down, but the cost was also pretty high on the Belgian side, on the defender's side. And we are now going inside of the fort, and we'll talk about every one of those shortcomings, whether they are building defect or design defect or other. We'll talk through them, and then we'll have the opportunity when we go to Aubin Fortress and Tancremont Fortress tomorrow. We'll have the opportunity to compare the old and the new as far as modern fortifications are concerned. One of the main issues with Brialmont Fort was ventilation. There was no mechanical or forced ventilation. We are here at Lantin Fortress in the head coffer. You can see the embrasure here for the 5.7 centimeter quick firing cannon. This is a cannon that was only firing grape shots. You see the embrasure here, and you see the shaft there. That's the ventilation for the whole casemate. So imagine firing a gun repeatedly, black powder obviously, imagine the amount of smoke created every time you open the breach, and the only way that smoke can go is supposedly over that shaft rising. You know that a lot of it is going to linger here, and after a while it's definitely going to incapacitate the gun crew, and it's what happened in 1914. The ventilation was simply not efficient enough. We were in the head coffer and I showed you how bad the ventilation was in the combat block. We are here at the base of the main ventilation shaft or F shaft of the fort. It's simply just a borehole going all the way onto the roof and opening. There's absolutely no mechanical ventilation inside of the fort. I mean, we are here halfway between the head coffer and the main assembly room. The main assembly room is surrounded by the large caliber gun turret. You would have a lot of hairs and a lot of smoke lingering throughout the fort as soon as those guns started opening fire. And they did in 1914, and any of you who has been playing a bit with black powder will know that it's a nice smell, it's not a nice smoke. It will end up, it's an acrid smoke. It will end up burning your lungs, burning the back of your throat, burning your eyes. The conditions here were not nice at all. I'm really getting dripped on as well. The conditions here were not nice at all. That is the only ventilation shaft for the heart of the fort, basically the center of the fort. We are here on the roof of Lantin Fortress, and we can talk here, discuss two more shortcomings about this design. The first one, as you can see, is the crown on top of the massif where all of the gun turrets are. The fort concentrates all of its armament very, very close to one another, and unfortunately, once the enemy has zeroed in its own artillery onto the middle of the structure, it's only a question of time before either turret get knocked down or the concrete around gets so damaged and there's rubble, everywhere, and you start jamming those turrets or you start obstructing field of fire and field of view. That was one of the major issue with the fort. Another issue, we don't see it here at Lantin because the Germans actually repaired the fort in 1917, I believe. But it had to do with the concrete. When the fort were built, all of the Brialmont fort were built around Liège and Namur. They were pouring concrete only during daytime. There wasn't enough artificial light source at night to carry on pouring the concrete overnight. The issue with that is that every day you'd pour a new layer of concrete and it would start hardening before the following day you'd pour another layer. And it looked fine as long as it was untouched. Unfortunately, when the Germans started firing on the structure in 1914, under heavy caliber or heavy stress, those layers started splitting, and it means, unfortunately, that the fort armor, the walls were not as strong as they could have been or should have been. Part of it was the pouring system, and the other part was this is unreinforced concrete. Tomorrow we're going to Aubin Fortress and Tancremont Fortress, and there obviously we'll see the difference with how in 1930, when they built those new modern forts, they took on board lesson learned from this first generation of modern fort to make them better and stronger. Okay, so we are here in the dry moat between the massif, so the main part of the fort, and the Counterscarpe. One of the issues with Brialmont Fort, the Brialmont design, was the Counterscarpe. Men fought and slept that side of the moat in the main structure, the main fort, the massif, However, all the amenities were in the Counterscarpe. Your kitchens, your bathroom, and so on and so forth. The main issue with that is peacetime, it's absolutely not a problem to cross the moat. In wartime, you can't do it safely. So the guys were staying there, you know, the fort was being shelled, they could not access the kitchen, they could not access hot food safely, they could not access the bathroom, and so on and so forth. It created a lot of issues. Unfortunately, the blame doesn't lay squarely with the Brialmont design. Alexis Brialmont, the architect behind this type of fort, wanted an underground tunnel to run from the Massif to the Counterscarpe, just as there is a tunnel linking the head coffer to the Massif. It's the bean counters at the government that refused and block the building of those tunnels, because it would have pushed the budget even further up. So it's not the first time it happened. Definitely wasn't the last time either that the accountants working at government level were responsible for the suffering of the people defending them. So we are here in one of the original, although modified, there wasn't any wood at the time, but we are in one of the original powder reserve of the fort. One of the issues with the Brialmont design is the all under one roof. We are literally at the same level as, on the ground floor, at the same level as the offices, the bedrooms, the relaxation rooms, you know. Guys were sleeping here when they were not, you know, alongside here, just on the other side of this wall, when they were not fighting. And at the same level, you have a huge amount of black powder reserve. There were two such rooms, slightly longer than what it looks like, and they were facing one another, with the doorways facing one another as well. So if there was a detonation in one, it would propagate into the second automatically. The other issue is that while the forts were very modern by 1885 or 1888 standards, by 1914 artillery had made strides forward, you know, strides ahead, and had become even more powerful. And not too far from here, you had Lantin fortress, which was a larger Brialmont fort, and it came under shelling by the Germans on the 12th of August 1914. And the Germans had brought in siege artillery, including the Big Bertha howitzer, firing 900 kilos, 42 centimeter shells. And unfortunately, one of them in Lantin went through the roof, straight into one of such room, one of the black powder reserve, and detonated 12 tons of black powder. That led to 300 to 350 men out of 550 dying on site. I mean, the explosion was catastrophic. If you get to go and visit the Lantin fort, the whole center of the fort has ceased to exist. It just disappeared. It's an enormous crater. That was a big issue as far as this fort was concerned, this design, the Brialmont design. It's a brilliant, brilliant design. But it came at a time where technology was evolving so quickly, the 1880s, you know, the early 1900s. And by the time it came, you know, time to fight, it was at a disadvantage. It cost the German a fair amount of men, you know, manpower and time to get through the Liège fortifications. And it may or may not, depending on who you ask, have slowed the Germans enough and diverted their siege artillery enough away from France to give time to the French to organize a defensive line at the Marne. But nevertheless, it came at a heavy cost for both parties in this war. The last bad thing we have to talk about with the Brialmont design is communication. Those came about, those forts were built in the 1880s. They relied on Morse code through a big searchlight at the top, and they relied on communication through phone lines, which were unfortunately attached to telegraph pole above ground. It didn't take long for the Germans to find all of those phone lines and start cutting them off. And obviously when you are under fire, the last thing you want to do is play around with a big searchlight at the highest point of the fort, even though the searchlight was armored. Is it something you want to do? Probably not. So they had problem. The fort had problem communicating with one another as soon as those phone lines were cut. Moving on to the design of the modern fort built in the 1930s, you have wireless radio communications, you have telephone communications, but those telephone lines were not overground anymore. They were entered pretty deep, linking the fort and the bunkers. The bunker bit is quite an important bit also. If you have a look at First World War forts, they relied on roaming patrols to come back and tell them where such and such enemy position is situated, so the artillery could engage them. You had some observation posts, church towers and so on and so forth, but they were pretty quickly found and neutralized by the Germans. And after that, obviously, all you can do, despite all the artillery you have at your disposal, all you can do is engage the enemy only within visual range. If you look at that lesson being learned, forts in the Second World War every fort had its own network of bunkers, which were the eyes and ears of that particular fort. They were overlooking important crossroads, important strategic position. They could see, pretty far away. They could pick up the phone, let the fort know enemy at such position, and therefore the artillery could engage them beyond visual range. All right, so we've seen Brialmont Fort, which is the genesis as far as modern fortification go in Belgium. Now we are going to head toward Tancremont and Aubin-Neufchateau fortresses. They are very, very similar, those two. And I wanted to show, I've used both forts to show you one modern fort. Basically, the footage are taken from both Tancremont and Aubin forts. They are very similar, as I said, but Tancremont is still fully equipped, while Aubin has a lot of his original equipment missing. Again, same concept. Everything is underground. You don't see much from the outside, landscape-wise. It's all flat, some packed earth, and then maybe a couple of gun turrets, just the dome poking out on the horizon. Dry moat, still there. Coffers to defend the dry moat, still there. One of the main difference between the two is the concrete. So on the Brialmont, you had simple concrete, unreinforced, non-reinforced. With the second generation, I would call, so the modern fort built in the 30s, you do have the use of reinforced concrete. The walls are much thicker and they contain a lot of steel. The fort itself, the structure, is much, much deeper underground. It's not just underground level. We're going between 28 meters, I think, in Tancremont to over 30 meters deep in Aubin-Neufchateau. And the other difference also is in Lantin, you had all of, on the massif, the roof of the fort, you had that crown of gun turrets very close to one another. Once the enemy had zeroed in his artillery, it was only a question of time before those turrets started taking damage, or the concrete around started taking damage, and then turret would get stuck, or you could raise the turret, but you couldn't see anything around. It was just full of rubble, full of debris, and therefore you couldn't fire. So if you look at the 1930s fort, what I would call the second generation Brialmont, but it's not completely or totally correct. All those turrets have been separated very far away from one another into combat blocks. So you have a monolith, which is the fort itself, 20 or 30 meters underground. And from there, you have shafts going all the way back to the surface, concrete shaft, supporting a structure or another. So you may have an entrance block, main entrance block. Typically, those had machine gun turrets. You have some gun turret blocks. You have at Tancremont and Aubin-Neufchateau also mortar block with mortars situated inside casemate. We'll go and visit them in a minute. And then you also had your ventilation blocks. While Brialmont Fort had everything contained within its triangle or quadrangle, the modern fort from the 30s cheat a little bit, and you have some structures poking out further up beyond the dry mode. So typically there's a second entrance, which is called the wartime entrance. You have a secondary air intake. You do also have observation blocks, which act as emergency escapes. So without further ado, let's go and have a look at Aubin-Neufchateau and Tancremont.
So we are here in a modern fort. This is Tancremont, compared to a Brialmont design from the 1880s. They've kept some of the things that worked, some of design features that worked, but introduced new design features learned from the hard fighting in the First World War. So they tried to remedy some of the failures and shortcomings experienced by the Brialmont fort in the First World War. So what they've kept basically is the dry moat with coffers acting as what would have been towers on a medieval castle. The coffers defend the moat. You have one coffer per side, and that will just provide close defense to the fort. The other things that they change is, instead of using normal concrete, they've used reinforced concrete, much thicker and more of it. Reinforced concrete is much more resistant to shelling than the concrete found on Brialmont design. The other thing as well is those combat blocks were built in one go. One of the problems with the Brialmont design was the concrete was poured during the day, not during the night. And unfortunately, in 1914, when German shells started falling, all of those different layers started separating. They had not bonded. Here, you have a continuous pouring of concrete to build the whole block in one go. Other things that were improved upon: ventilation. You now have forced induction and ventilation, mechanical ventilation throughout the fort, meaning any smoke and gases produced by firing the guns are forcibly expelled out of the structure. You also have, we'll see it when we're on the roof, but you also have, instead of one big monolithic structure as the fort, you basically have combat blocks with just dirt around. The combat blocks are linked 30 meters underground, so it is no longer possible to target all of the armament of a fort at once, as it was possible in 1914. The all-under-one-roof solutions, where soldiers were fighting, sleeping beside the ammunition reserves, all under the main roof, that's gone. So you have the fighting blocks, and then you have the underground barracks, which is separated. You fight, you do your 8 hours, and then you go in the underground barracks, and you basically, you don't hear any of the fighting, you don't hear any of the noises, you don't hear, your colleagues running around and so on and so forth. Ammunition stored just under the roof, as in the Brialmont design, that's gone. The ammunition are now kept, the shells are kept in each combat block, again 30 meters underground, and with added security safety measures. So they've learned the lessons of the First World War, and they put them into practice when they built those forts in the Second World War. We are here in one of the Fort's 2 air intake station. Basically, that big tube could be raised
up to 18 meters up in the air. And when lowered, it would literally be lowered flush with the ground. So one of them had to be operating at all time. The air would come out of here and be sucked by a huge fan here, which is next door. The fort required the air intake station to pump 35,000 cubic meter of air an hour. So that's an enormous amount of air being sucked into the fort every hour. That was what was needed for the air inside the fort to be breathable, everything ventilated properly, and most importantly, all of the combat block being pressurized to, I think it was 15 millibar. So it was just enough to keep the inside pressure slightly higher than the outside atmospheric pressure. All right, so this is the machine room. This is where power is generated, and it is also where hot water is created. So you had 4 of those engines running in the fort, not at any one time, but you had 4 of those engines. 2 running at any one time, 1 being maintained, the service being done on it, and 1 ready to go as a backup if one was to fail. Those are actual boat engines, and they're each mated to a dynamo, basically. Water cooled, cold water would go into the engine, come back fairly hot, create some hot water for the shower room, which we'll go and see soon enough. And then the hot water was circulated through hot water pipes and radiator throughout the whole building. They would come back through the extractor fan, which we're going to see in a minute. There was a big radiator in front of the extractor fan. Hot water goes through radiator, is cooled again, gets into the engine, cools down the engine, and the cycle carries on. So it's a closed circuit. It's very clever. The fort had between 7,000 and 8,000 liters of diesel in reserves, which was thought to be enough for a whole month of operation. Those machines produced the electricity for 87 electric engines throughout the fort, as well as 800 light bulbs. All right, so this is the extractor fan. There's 2 air intake stations in the fort. Circulates air through the fort, ventilates combat blocks and accommodation, and more importantly, pressurizes the combat blocks. Pressurizing the combat blocks was very useful for 2 reasons. 1, it's to expel all of combat gases when you're firing your machine guns, automatic rifles, or the main guns. But 2, again, in the 1930s, chemical warfare from the First World War was still present in everybody's mind. If you pressurize the fort, if air pressure inside the fort is higher than outside of the fort, any chemical attack, gas attack against the fort wouldn't work because the air pressure inside the fort is higher than outside, and enemy gas wouldn't go inside of the fort. Nevertheless, you have air intake stations circulating air through the fort. It needs at some point to go somewhere, and this is where it's all sucked in. There's a whole network of pipes throughout the fort and inside of the barracks, sucking all of that dirty air, bringing it here, and from here it is expelled through the chimney system. So 2 reasons for that. 1, you had your radiator there, cooling the water down, the water from the central heating, so the water was cold enough to cool down the engines in the engine room. And the next reason is you have a hell of a lot of air coming through here, bursting into the chimneys, and that would push the exhaust gases up into the atmosphere. Without pressurizing your chimneys, all of the exhaust gases would lay low into the block and end up seeping back into the fort, literally poisoning everybody. So with that system, you actually pressurize also your chimney block and expel all of those gases and all that smoke all the way up. Throughout the chimney, you had the dirty air coming from here being expelled. You had the exhaust gases from your diesel engine in the machine room, and you also had some pretty dirty black smoke from the kitchen, because the guys in the kitchen were using coal-fired cookers
to cook the crew's meal. So all of that needed to come out. So this is the chimney block. You have, in the engine room below, you have 4 diesel generators that are actually ship engines. You have 4 diesel generators generating all of the electricity the fort needs, as well as providing hot water for showers and so on. Obviously, the exhaust gases need to go somewhere, and they come through those chimneys. So the design of this chimney block is pretty interesting. Each chimney duct is in the shape of an inverted Y, and anything you would drop from the top would always end up in the dead end rather than roll all the way down through the exhaust shaft and into the machine room. So they were designed, even if the fort was swarmed and you had the enemy rampaging on the roof and dropping demolition charges through the chimneys, they were designed to carry on functioning without damage being done to the engines. In a possible case that those 3 chimney shafts were to be damaged, you actually have 2 smaller emergency chimneys somewhere else on the roof. So you always have here a backup as with every system on the fort, really, you always have a backup.
So right now, I should be taking you through a tour of the command center. You should see yours truly, talk to the camera, and take you through the 5 rooms. We were there. We thought we recorded it. I spoke to the camera. We forgot to press record. So we'll have to do it another way. So this is a blueprint, professionally made, may I add. This is blueprint of the command section. I'll add some pictures as I go through. So this is a command center, and this is where basically all the information from the outside world would come in. This is where decisions are taken as to what to fire at and how, and also from where the fort communicated with the outside world. You have your commander's office. This is basically where all decisions are taken. And then it is passed on to either the left room or the right room. The room to the left of the commander's office is the small arms room. This is where the deputies, the commander and the deputies can communicate with machine gun cupolas, as well as, in case of Aubin and Tancremont, the mortar crews which are in the mortar block. Or you have the room on the right of the commander's office, and this is for the long range weapons, so the gun turrets. In the case of Aubin and Tancremont, 75mm gun turrets. And on the other side of the corridor that passes through the command center, you have your telephone exchange and your radio room.
We are here in one of the 2 filter rooms. Unlike French fort, where all air was purified or filtered before being circulated through the fort, Belgian fort didn't really filter the air being circulated inside the structure. They basically tried to compensate for that by sucking the air from a height of over 18 meters. Combat gases tend to stay at floor level. By sucking air from 18 meters up in the air, they thought that they were taking reasonable precautions in circulating clean air through the fort. However, all of the servicemen were still carrying a gas mask. They were still drilled in chemical warfare, and there was still a gas alert, in existence just in case. Should there be need to filter the air, they couldn't filter the air being circulated inside the fort, but they could filter the air being circulated in the barracks. And this is one of the 2 air filter rooms. Clean air from outside would be circulated through those filters and then sucked in through a fan which is behind the camera and circulated into the barracks. So I am in one of the 4 showers in the fort. Look at that. beautiful. There were 4 showers for a crew of 500. So basically, it's 1 shower per person per week. It's not nice, it's better than nothing. Keep in mind, we're in the middle of the countryside, Belgium, in the 1930s. Most people didn't even have, most of the guys that served here didn't even have a bathtub at home. They probably had a tin bath. So for them to come around here and have running hot and cold water shower, it was something out of the future. For us, we take it as granted, but it is how it is. And you have a rotation system with sliding doors. And you basically had a person washing, a person drying, waiting to come out, and a person there getting naked, getting ready to come in. So you had a constant rotation when it was shower time. I don't think you could spend a lot of time under that shower, but you had a hot water shower once a week. We are here in the washroom. So we visited the shower room where people could have 1 shower per person per week. The rest of the week they could come and have a quick wash on those. This is where they would do their quick ablutions, a quick little wash off. They had foot bath. It seemed to have been there seemed to have been a big emphasis on that in the First and Second World War. Pédiluve, they're called in French, so foot bath. I suspect it's because a lot of people before they ended up in the army with big army boots were wearing wooden clogs. So taking care of your feet was very important. Those were used not only to have a quick wash, but also to do your laundry by hand. All right, so we are here in the toilet inside of the barracks. So as you can see, those are squat toilets, as we've discussed. You have the same toilets in every combat block. You have a fair few here in the barrack. It's not being evacuated anywhere. It goes into a septic tank, which needs, when it's full, to be emptied with a giant ladle into buckets, which are then evacuated outside. Not the best of jobs, not only that. The other problem is, during the siege, they could not be evacuated. We spoke earlier on about how the odorless buckets were being accumulated in corridors because they could not be brought outside safely to be emptied in the field. It was the same with the septic tank in the fort. And by the end of the sieges of those forts, Aubin-Neufchateau, the siege lasted 12 days. It must have been pretty full. In the case of Tancremont here, the siege lasted 18 days. The toilets were on the verge of overflowing. And if we go that way, we can see that the first thing the Germans did when they took possession of the fort was to seal the toilet door, and plaster that door with newspaper to try and stop the smell seeping through. And there's actually a couple of newspapers. If we have a look at the titles and so on, it comes from a German town which is now in Poland. Yeah. Well, we are in the kitchen, and you can see along the wall where the 3 big coal-fired cookers were. You can still see a fair amount of soot, actually. Wondering how smoky the kitchen was at the time. This is where the meals were getting ready for the servicemen. So for what I've been told, they had 1 hot meal a day. You always had some potatoes, probably a bit of meat, some kind of stew. But that was 1 hot meal a day. The rest of the day they had coffee and they had hardtack. And that was it. So 2 meals of hardtack a day and then a real hot meal at the end of the shift. Here in a room with tiled floor. The other room with the tiled floor is the fire and control room with the commander's office. So this is part of the medical center of the barracks. You have a crew of 500 people. You need to take care of them. So you had a room where you could go and talk to your doctor. You had a pharmacy. And you have this. So you have your 3 rooms here. You have your anesthetics room, you have your sterilization room, and you have your operation room. The operation room gives way straight away. It has a direct access to a hospital room next to it, or recovery room. As you can see, those rooms are not only tiled, but they have running water, there's a tap and a sink there, and they have radiators. When we'll go to the hospital room, you will see that they have additional hot water pipes along the wall to keep those guys a little warmer than elsewhere in a building. So here are your additional hot water pipe. It doesn't look like much, but at the end of the day, if you go in a crew bedroom, they only have one length of hot water pipe running along the bedroom wall. So this would create a little bit more heat. There's a lot of moisture here. There was still a lot of moisture even when the heating was on. I mean, at the moment it's about 12, 13 degrees. With the heating going on, you could get it between 18 to 20 degrees. I mean, it's not tropical, but it's better. You still had a lot of moisture though. You talk to the veterans and they tell you they would keep the toilet paper inside of their shirt to keep it warm. Because if they didn't do that, it would turn into mush. It's the same when the guys were washing their clothing. Well, they didn't have tumble dryers available, so they had to hang their clothes. If you were hanging your clothes just in the open, it would never ever dry. You could try and wring it really hard and then put it back on, and eventually your body heat would dry that clothes, but how uncomfortable would that be? But that was an option. The last option was to take your freshly washed uniform and put it on one of those pipes, which already back then were covered in rust. So your freshly washed top would dry, but would be dirty by the time it was ready to put back on. So the guys did not have a very comfortable life down here. So throughout the fort, you have either odorless bucket or squat toilet, just a hole on the ground. Here, because we are next to the infirmary and the sick bay, you had actually proper toilets with a bowl flush toilet. And that was to prevent the spread of disease. If somebody had a bug and a poorly belly, you didn't want that person to go to the squat toilet and basically repaint the whole cubicle. So they'd come here, they'd use the proper bowl, they would flush, it would be kept separate. And it happens that those toilets are also fairly close to the officers' room. And there's probably a fair chance that the officers will also use the proper toilet rather than the squat toilet. We are in one of the 2 well rooms. So we are 27 to 30 meter underground, and we are on top of a 27 to 30 meter well below us. It's designed to capture any water draining through the soil. And then here it was pumped, checked, and if needed, sanitized. But through this thickness worth of rock at this depth, you can tell it's just pretty good, pretty pure water. But they had everything they needed to check the quality of the water before dispensing it. So that water would be used to top up the heating system. That water would be used for drinking water, cooking, cleaning. It would also be used for the showers. We are here in a troop bedroom. Basically, the walls would be lined up with bed. It wasn't a nice experience. We are inside of the main barracks. You had one bed for 3 people. So basically they were working, So you basically were working the 3/8. There were 3 shifts per day. And they were using what was called the hot bunk system. So you get out of your bed to start your day, and somebody is next to you waiting to jump in. So the bed would always stay warm from somebody else. It's a lovely concept. But you make it with 3 times less bed than needed. It wasn't a nice experience either because there's a lot of moisture in the air, and they didn't put radiators in for the soldiers in the soldiers' bedroom. For one simple reason, they would all be fighting, trying to get the bed next to the radiator. So instead they had a hot water pipe running along the wall, all along the room. So nobody's fighting for a pipe. Everyone had a portion of that pipe. We're now going to go and see the officers' bedroom, and in there we'll see that officers had a radiator in their bedroom. So this is an officer's room. This one is equipped, although somebody ran away with a tap. But it still has its little sink, and we can see, as an officer, they had their very own radiator. We are here in the officers' mess. As you can see, they had a little bit more comfort. They had their own little sink and tap and an echo. They had a radiator and a room decorated in Art Deco. This is where the officers would come round and chill and probably drink a little bit of Picket when their shift was over. Okay, so we are in one of the 3 Picket rooms in the fort. The Picket room was basically where engineers slept. Everybody in the fort sleeps in the barracks. Engineers do not. Engineers need to be close to where the machinery and the armament is, so they can intervene faster. Those guys were maintaining, repairing all of the fort systems, but they were also in charge of any demolition work needed to be done, and obviously if the fort is at risk of being breached, they need to be very close to the site and intervene very quickly, set up demolition charges and set them off. So that is where they used to sleep. They had a little bit more comfort than the guys sleeping in the barracks. They had radiators for a start, and they had their own bed. They didn't have to share their beds with other people. What we have behind us is an enormous shelf where all the demolition charges for this part of the fort were stored. So as an officer, you'd sleep right next to several hundred kilos of explosives and their fuses, so pretty good. We are here in one of the 3 other radio rooms. There's actually 4 radio rooms per fort, one in the command center, and then the other 3 dispersed around the fort. So this is one of the auxiliary radio room, and in this one you actually see the well for the antenna. So the radio sets were here along that wall, and then the cable would go all the way down that well and connect to the aerial that could go all the way 30 meters up. From the outside it really just looked like a steel mushroom, just flush with the ground. An interesting thing from this room is the sign just behind the cameraman or the camera woman. Basically, do not park here. The main reason for that is some people during the war were using bicycles to go through the galleries of the fort faster. And if you put a steel frame that close to the antenna, you're going to cause some interference of some sort. So you could go around with your bicycle, but you could not park it here just next to the radio set. So this is B3. This is the peacetime entrance of Aubin Fortress. We see the inner postern there. We'll go through there in a minute to go inside of the fort. As you can see, it was defended by a machine gun. That was a First World War Maxim, which was rechambered in Belgian Mauser. And you have also an embrasure there for the searchlight, which used to shine straight into the main postern, the access to the fort. It's a big unit. The thickness of the wall is about 2.5 meters in thickness for the outer walls. Roof 3 to 3.5 meters thick, and it was defended by 3 machine gun cupolas. Okay, so this is a machine gun cupola. You had 3 of them on top of B3, the peacetime entrance, at Aubin. You also have 2 of them per gun tread blocks. Those machine gun cupolas are pretty deceptive. They're much bigger than they look. These weigh 48 tons. That's 48 tons worth of nickel chrome steel, 32 centimeter in thickness for the armor. And right there you had a Maxim machine gun. You actually had a double mount, a twin mount. So you had 2 machine guns on top of one another. If one would jam for a reason or another, you only had to unhook a couple of things, flip it 180 degree, rehook it, and carry on firing. They were water cooled, but each of those embrasure had a little radiator. So the whole thing was geared up for heavy fighting and high rate of fire if needed. On top of those machine gun cupolas, you always have an opening. Some of them it was for periscope, and some of them it was so you could fire flare for artificial lightning in the middle of the night.
And once again, back to the studio, because we forgot to press record for that video also. So we are right now looking at a B3 in Aubin-Neufchateau Fortress, which is the peacetime entrance block. Now, to access it, you need to walk over a rolling bridge. Obviously, that bridge would be retracted in case of conflict. The gate would be closed, the bridge would be retracted, and assailants would be faced with not only a pit in front of them, but a casemate with an automatic rifle facing them. So that was the first line of defense. Beyond that rolling bridge, you also had the armored doors. And obviously inside of a B3, so inside of the entrance block, you have the goods lift to bring officers and sundries inside of the fort. Soldiers would have to take the steps. So I believe in Aubin you have 120 steps to go down. The officers do take the lift, not the soldiers. You also have the decontamination rooms. That's harking back to World War I and combat gas. So if somebody had been exposed to gas outside of the fort and was brought in, there were facilities inside of the entrance block to decontaminate both the soldier and his uniform, and therefore make both of them safe to go inside of the fort. And then obviously you have in that combat block also the casemate facing the main entrance, the main access inside of the moat, with a searchlight and a machine gun. And you have also access to those observation cupolas and machine gun cupolas, which are part of the block.
All right, so this is a Maxim machine gun mount. We are here in the entrance block, and as you can see, it still rotates, and you can still change the elevation. So this is a twin mount. You had a Maxim machine gun at the top and one at the bottom. The top one was the firing one. If it jammed, which could happen, you only had to unlock the ammo feed and this tube, rotate the mount 180 degrees, reconnect the ammo and that tube, and you were firing again. As you can see, the firing port is not very big. You don't really see a lot outside. You really see just in front of the embrasure, and that's about it. The tube here was connected to the ejection window of the Maxim gun, and that was to collect. We've just kicked a shell. That was to evacuate your brass, your spent cases out of the way into that box, so you didn't have a trip or slip hazard. Another interesting thing, the Maxim machine gun was designed to be water cooled. Here's your water tank, and the water would come down from that beautiful little spout here through a pipe into the machine gun, come out of the machine gun and connect onto that little radiator, which would then come back out and link back onto the reservoir, onto the water tank. You have here a constant flow there. This is a combat block, therefore it is pressurized, and the pressure needs to go somewhere, and some of it goes through your aiming windows, meaning you have a constant flow of cold air coming flush with the water radiator, cooling the radiator, cooling the water that was in turn cooling the machine gun. Okay, so we are here at the bottom of the stairs from the peacetime entrance block. And as you can see, we are in a lock. You have an airtight door, that's a combat block, therefore it is pressurized, therefore you need an airtight door. And you used to have over there a reinforced door, an armored door. You have grooves on the wall, and that is to condemn the block in case the entrance block, the surface block, is compromised and the enemy may take foot. You basically fill those grooves with steel beams, sandbags, more steel beams, and then the fort is sealed from the outside world, at least as far as this block is concerned. You have your shelf with explosives at the top, your demolition charges. You set them off, the whole staircase collapses, the ceiling collapses on top of that door, and then you have the added protection of your steel beam and sand barrage. Nobody's going to come that way. You, as the defender, you still have some options. There's many other ways of getting out of the fort, but at least the enemy will not come this way if it has gained a foothold upstairs. The entrance combat block. So it sucks air from inside of the galleries, and the air comes back on the other side. It comes from here, the air is sucked here from the gallery and comes back out through this grate on the other side of the airtight door and pressurizes the whole combat block from the bottom of the stairs onward. Okay, we are in one of the ammunition reserve in the fort. There's a pretty nice graffiti here. Long live Neufchateau Fort and our commander. 10th of May 1940, first day of the war. And then 6:07, which is the time at which the fort fired its first round. The guys were sleeping on outdoor barracks, more comfortable than down here in the damp. So they were in a peacetime barracks, and they were roused in the middle of the night and told to take all of their belongings and go inside of the barracks. They were not told we were at war. They were not sure if it was a drill or not. And then the gun turret crew from B1, we are in B1, received some coordinate and a number of shells to fire on that coordinate. That was at 6:07 in the morning. It's only after that they were told that they had engaged a German patrol. They knew then we were at war. And here we have the leftovers of some calculations from the crew accounting for some of the shells they were bringing up into the lift and into the gun turret above us. All right, so we are back in a gun turret block. We are here all the way at the bottom of the fort. So we've got the ammunition reserves over there. We've got the fuses kept in separate cupboards, and we are now ready to send some ammo fitted with a fuse up to the gun turret above. So you have two ammo lifts. The shells were loaded onto a little wheeled chariot that were in turn loaded onto the lift, and that would be brought up all the way up 1 story below the gun turret. We're going to climb all those stairs and then see the 2 sub-levels and then the gun turret itself.
Guess what? There should be a video of me taking you through the machinery room, which is two stories below a gun turret, but it didn't happen. So I'll show you pictures instead. Basically, those gun turrets were about 120, 130 tons. They're heavy, and they could rotate 360 degrees. They could also be elevated, raised, or lowered, eclipsed. And you needed a fair amount of machinery 2 levels below that to get them to get that to happen. And so what you see here is a collection of pictures, and you see the electrical and the hydraulic system that was used to raise those turrets, lower those turrets, or rotate them. And what you also have beside that is the backup system, manual system. So should there be a problem with power, or should there be a problem with mechanical issue or hydraulic failure, you could still raise and eclipse those gun turrets as well as rotate them manually. Apparently you can raise that 120-ton turret with 2 men, although 3 would be a bit better.
All right, so we are first sub-level. This is the counterweight and hydraulic level. So it's all really for the operation, not the operation, but more the heavy lifting of the cupola. So the gun turret is 120 ton in weight. You obviously need to counterbalance that with a 30-ton counterweight at the arm, at the end of this arm here. So on the other side of that room, you have your counterweight. And here it's the backup hydraulic system. This powers some rods situated under the gun cupola, the gun turret. It's not designed to raise the gun turret all the way up, but just in case if it's find itself a little bit ajar or stuck, they can try and use hydraulic brute force to straighten it back out, lift it back up, and drop it back straight, where the normal operation can resume then in eclipsing the turret or raising it back. Also, around the corner, you have your crew toilet, and you have access to the gun turret from that side.
So as you know, we've already explored, underground, 35 meter underground, the ammo storage. And those shells would be loaded onto the lift. And the lift would arrive 1 story below the gun turret. And here you see the panels where the chariot, the trolleys full of shells would be brought against, so you still have a seal to maintain positive pressure inside of the gun turret and the combat block. And you had guys grabbing those shells out of the trolley and putting them on the Noria. So here you see the Noria, and that would be rotating. So guys could be loading those little shell buckets basically non-stop. And then right on that platform, you had other guys who could just take the shells and put them into a shell lift. And those shells would be lifted all the way to the floor of the gun turret. And the whole system is designed so the gun turret can rotate independently, and the guys at the level below can still get some shells, put them on the shell lift, and send them up onto the gun turret. You had a maximum of 3 or 5 shells, I believe, on the floor of the gun turret to avoid any issues, any big explosions, should there be any problems. And obviously the gunners in those gun turrets could just grab them, load them onto the gun, and send them to where they were meant to be fired at.
So we are inside of the gun turret. As you can see, it is very, very crammed in here. Despite that, in May 1940, you had a crew of 5 working here at any one time. 5 people in such a small space. It just beggars belief. That's not something I would have wanted to do ever. You've got your 2 75mm guns, one on either side. 75mm gun, maximum range 10.1 kilometer. Maximum rate of fire for long period of time, 12 rounds per minute. Per gun, so that's 24 rounds per minute per gun turret. You could increase the rate of fire to up to 15 rounds per minute for a short period of time. 15 rounds per minute per gun for a short period of time. The 10.1 kilometer range was enough for forts to target one another, to provide one another with fire support, and it was more than enough to target all of potential targets in the area of responsibility. Each fort was assigned an area of responsibility and strategic point within that area to either defend or destroy. Those guns are fitted in a gun turret that weighs 120 tons, so you have a very, very stable firing platform, meaning you have a very accurate firing platform. Being a gun turret, it can rotate 360 degrees. You had 6,400 angular mil per 360 degrees. And the theoretical accuracy of the gun was 1 angular mil to the kilometer. Those guns exceeded that. They were very, very accurate for most of their theoretical range. You have some manual control here for manual targeting. That's really for close defense only when firing grape shots. The rest of the time, it's all done downstairs. The guy receives a set of coordinates, aim the turret in the right direction, tell the gunners here to set the elevation to X degrees. The turret is raised, and then they start firing X round per target. It depends really on what target they have to intercept or what they have to destroy. They have a phone. They are in contact, obviously, with the command center downstairs. And as you can see here, when the spent case was ejected, it was directed straight 2-story down into an airtight room, which was ventilated. So none of the gases contained in those spent cases would stay here and linger inside of the gun turret. They would end up 2-story below, being ventilated and being cooled down. This is one of the fort's 2 main gun turrets. It's equipped with 275mm guns. This weighs 120 tons. The dome, the armor on the dome is 43 centimeter thick, and on the side 38 centimeter thick. This could be raised in 16 seconds before the gunners could open fire, and then it could be lowered roughly again inside of 16 seconds. Rotation speed about 6 degrees per second, so a full 360 degrees would take a minute. Saying that, you could rotate it when the gun turret was eclipsed, so the only thing visible from the outside would be the very thick dome, the armor, and the guys would just turn the turret in the exact angle they needed it to, raised it, and then started opening fire. Obviously, those guns are for long-range shelling. They could be used for close defense, firing grape shots, but their main job really was to engage the enemy at long range. So sighting the turret at the right angle before raising it was always an option. So we are at the bottom of the mortar block, and what you have around here is 1, 2, 3 ammunition reserves and 1, 2, 3 ammunition lift. Upstairs you have 3 mortars, so each mortar has its own separate supply of ammunition. If we were to go and have a look at the ammunition reserve there, you'd actually have 3 different rooms. One for the projectile itself, one for the fuse, and one for the powder charges. So the guys set them up there behind this blind, and then just set them up here, and they go all the way up. You've got the stairs, and if you look closely at the stairs, they are hinged. So you can actually lift the staircase out of the way if you need it to carry something heavy across this corridor. We are now going to go all the way up into the mortar block and talk a little bit more in detail about this weapon platform. So we are now just under the surface in the mortar block, and as you can see, we've got a mortar behind me. We have one there and we have one just behind the camera. So you have your 3 mortars. You also have 3 mortar crews, 5 people each. And you have 5 hooks. You come here on duty, you put your little bag with your little picnic and your personal effects on the hook, and if an officer comes up, he can see if we've got the total of 15 people working here on duty, if one of them is missing for some reason. Other nifty little thing, the walls are white to reflect light, however, they're dark at a lower level. It's so you can just put your feet against the wall without tarnishing or dirtying the white wall. You've got your 3 ammunition lift for your 3 mortars. There's one per mortar. That's nifty too. And then here's one of the babies. So this is a breech loading 81mm mortar. It's actually a French model, although the ammunition was manufactured here in Belgium. You put your powder charge and you put your bomb and off it goes. 8 rounds per minute, that's the rate of fire. Maximum range 3.6 kilometers, so that's not a long range weapon at all. It's more for close defense of the fort. It is first and foremost an anti-personnel weapon. The range was modulated by varying how much pressure you wanted to escape out of the cylinder. So you could vary the range of the weapon depending on the powder charge you'd put, and also through a vein you could let more or less of that explosion escape. You close the vein, 100% of that explosion from the charge would propel the bomb out. You open the vein a little bit or more, some of the gases escape over here, you've reduced your range. Another last good thing to see is that here we still have a spare tube in its original box. This is a spare, unused 81mm mortar tube, just in case. There's one here. That's it. This is the mortar block. Only 2 of the Modern Fort had mortar blocks, Tancremont and Aubin. You can see there an observation cupola. The thickness on the armor there is 27 centimeters, and you had a 360-degree view around it. You also had extra armor on the inside to cover the embrasure, and you could open and fire with an automatic rifle. It's a very interesting system, this mortar block. You have 3 mortars. Each mortar covers a 90-degree angle, so you basically cover a 270-degree arc of fire with those, and the block itself is protected in such a way that it is almost impossible for an enemy shell to score a direct hit on the mortar embrasure. So you have a large and deep pit where a shell coming in at a high angle would fall in straight away, and you have some kind of cap there, a big forehead, which would intercept a shell flying at a lower angle. It would intercept it before it hit the embrasure. Obviously, the pit is also there to stop any intruder on the roof making its way to the embrasure with demolition charge, and also to collect falling debris in case of shelling, so that the embrasure stays unobstructed at all time.
All right, and this is it for this time. Really sorry about the quality of the work. This was the first time we did something like that, and we were still getting used, 1, to me talking to the camera, 2, to the equipment, getting used to the equipment, and 3, trying to piece all of this together. And then obviously you have video edition, which I'm still new to. I hope you enjoyed this virtual visit. I hope you learned a couple of things. If not, at least this would have given you some insight into the life inside those forts at the time, and how the fighting was done. I am going to try and do more of those types of videos. The aim is to go to Belgium at least once a year and try and make more videos on that type of topic. Now, obviously, this was a very broad introduction to the world of Belgian fortifications. If you want me to get more in depth with one thing or another, one type of fort or another type of equipment, or whatever, by all means, do comment, do give me some feedback, and I'll know what direction I need to pivot toward in order to give you the type of videos you guys want. So thank you very much, and I'll see you next time.
See?
You can see your blue light.
Meow. We good?
Yeah.
Is it still recording? Is it still blue? Recording?
Yeah.
Woo! She's recording. Yeah. We good?
Ready.
Oh, it's on.
Ready.
We good?
Yeah. Yeah.
All right. When you are ready.
And your big lighters for life.
Yeah.
The blue light on your side. All right. You can press record then.
I did a long time ago.
What? Shame on you.
Memory card's already full.
It's going to be a long edit. I mean, can't you smell it? You have species of mushroom growing on it that nobody knows about. You tell me when you tell me.
All right,
Hey?
Ready.
Are you recording?
Yeah.
We promise. I see the blue light, right? You had a hot water shower once a week. Done. I'm really blind now. We good?
Yeah.
All right. It's a lovely drop of beer, this. No. You recording? Back off. Right, we are here. Oh, a bat. Well, I've got them.
My imagination.
Obviously, didn't do it. No. I think that's it. I think it's time to go and drink something, isn't it?